All right, ready for chapter 4? We're going to start 4.1. Chapter 4 is quite a bit a continuation from what we learned in chapter 3. It's a very short chapter. I think in total there are 5 lessons. So again, for as long as this is going to last, I'm going to attempt to mimic what I would do in the classroom for you on video in terms of what the note would look like. Just a reminder, all of these notes are available on D2L with the full solution, so you don't necessarily have to be copying really quick while you watch this. You can fill things in, but the filled in version is out there, so you can print them from home or do whatever you need to do. Okay, chapter 4 is going to start with solving polynomial equations. So we were already factoring polynomial equations, and we are going to continue to do just that. We're just adding one small step to it. So if you remember when we were factoring polynomial equations, so we had some equation p of x equals some polynomial of any degree, degree 4, degree 3, whatever we happen to have. The key was we wanted to find a k value that allowed p of k to equal 0, which meant you needed to find some number that you could substitute in for x, we're calling the value k, and when that number got substituted in for x, the answer was 0. That meant we had a remainder of 0. That gave us our first factor. Once we knew a factor, we could set up synthetic division, use that to factor again. If it was a quintic or quartic function, you would have to do synthetic division multiple times until you got down to a degree 2 polynomial, in which you would use just normal factoring methods from grade 10 and 11. So that was the idea. Now, when we do solving polynomial equations, there's 2 things you have to look out for. First, you have to look for what sort of restrictive domain does it have. So this one is saying we only want to find positive x values. Could you possibly have zeros that are negative? For sure. Do we care about them in this question? No. We only want to be concerned with the positive values. Okay, so that's the first thing. I've underlined that. And for values that specifically make this function equal 10. So what that's saying is, here's a function p of x, a quartic function, so to degree 4. And we're saying we want to solve when this exact function is equivalent to the number 10. So everywhere I see a p of x, I am substituting in a 10. The rest of the equation is exactly as it was before. So when I put in the rest of the equation, x to the 4 plus x cubed minus 16x squared plus 26x minus 2. So all I've done here is substituted in a number for p of x. This is the big step. And now you bring that 10 over to the other side and you just factor the polynomial the same way we did before. So when we bring the 10 to the other side, we're making sure that this is a 0 over here. You can't factor something unless you have a 0 on that side. So there's no like terms for the power of 4, power of 3 squared, or the 26x. When you bring the 10 to the other side of the equation, just remember to change the sign. It becomes negative 10. Negative 10 minus 2 is negative 12. Okay, so when we get to that, at this stage, you are going to do the exact same thing we have already been doing in chapter 3. Factor. Okay, the question is, how do you factor? We just went over that. You find a value. Okay, so maybe now you're calling this is a new function, p of x. Maybe you call it like p of x star or something. You can make up something a little bit different to identify it as being a different equation. And again, you are looking for a value of x which makes this become 0. Okay, now you have developed your own methods for how you do this. It's mostly trial and error. We know it's mostly trial and error. There is some thought to the idea of, you know, if you look very carefully here, this is negative. If you just look at the signs, negative 16, negative 12, that's negative 28, positive 26, positive 1, that's positive 28. So all of a sudden you know, oh, negative 28, positive 28, if you just put a 1 in, those will pop out to be 0. So you can kind of look at it and assess. You don't have to pick random numbers. You're not picking, oh, maybe 5 works, maybe 7 works. Start with 1s and 2s, or negative versions. Okay, so I happen to look quickly. I know that when I substitute a 1 in, 1 to the 4 is 1, 1 cubed is 1, negative 16 times 1 squared, and I know this equals 0. Okay, so I now know my first factor is x minus 1. Okay? So that's the kind of the first main thing that you need to know, that x minus 1 is a factor. Once you figure out x minus 1 is a factor, you're going to go and start doing synthetic division. I'm going to leave the question up here and just erase sort of what's in the meantime, because I'm going to want to re-reference the question once I get to the solution. So I'm going to erase this part for a second and just set up the synthetic division to show you what the next step would be. Okay, so it says x minus 1 is a factor. What does that mean? It means when I set this up, I have a 1 there. Now I have to go back and look at what my original question was. I had a 1x to the 4. I had a 1x cubed. I had a negative 16x squared. I had a positive 26x. And on the end, I had a negative 12. Okay, so you have one piece of paper. That's easy enough for you to do. Remember the steps to synthetic division again. Drop this down, right? When I drop that down, I get a 1. Multiply. Add the columns. Multiply. Add the columns. Multiply. Add the columns. Multiply. And what do we have to get here? A remainder of 0. So at this stage now, I knew that this was a factor. Well, my next one, remember, constant, degree 1, degree 2, degree 3. So this is x cubed, 2x squared, negative 14x, plus 12. That's so far what I've got my original thing to factor to. Well, guess what? We still have a cubic. We have to get it down to a quadratic. So we have to do synthetic division again on this. So sort of temporarily I'm saying, okay, I know this is a factor. Keep that in mind. And now I'm calling this new thing another p of x, basically. If I call it another p of x, it will help things go a little bit faster. So now I have my next thing, p of x is x cubed plus 2x squared minus 14x plus 12. And again, you are now trying to find a number that when you sub in for x, this whole thing will be 0 on this side. Okay? So through a little bit of trial and error, you might sit there and try 1, doesn't work. You might try negative 1, doesn't work. Because I'm sitting here with solutions and not a lot of time on my hands, I can tell you that 2 is going to work. You substitute 2 in. So it's just a straight substitution. Let's just make sure we get the right answer. So 2 cubed is 8. 2 squared is 4 times 2 is 8 again. Minus 28 plus 12. 1628, yes, that is in fact 0. Okay, so now I know x minus 2 is also a factor. So on the bottom here, I'm just going to write what I already know are factors. 1 is a factor. 2 is a factor. And we still need to figure out what's left there. Okay? Again, I now have to go back up and do synthetic division a second time. Once I do synthetic division a second time, I should be well on my way to figuring out what's going on. Okay. So, again, I'm erasing part of the question, which is a little bit annoying. Okay, so I just found out that 2 is one of my factors. So you again set up synthetic division. This time we had x cubed 2x squared negative 14x plus 12. Okay, and again at this point, you are bringing the 1 down and then using synthetic division the normal way. So when I bring the 1 down, I then do 1 times 2 to get 2, add the columns, and I get a remainder of 0. So remember, I already had this, x minus 1, x minus 2. And then what's happening here? Constant, degree 1, degree 2. So I have x squared plus 4x minus 6. I now know those are equivalent to my original p of x that I had, right? So the question is, I found 2 of the factors. Is it easy enough to find that factor? The answer is yes. You may try to factor using normal trinomial methods and realize that it does not have integer answers. So when it doesn't have integer answers, unfortunately, at that stage, you have to look at this and say, use the quadratic formula. You can't factor that unless you use the quadratic formula. So again, just for reference, to use the quadratic formula, negative b plus or minus square root of b squared minus 4ac all over 2a. What exactly are our values? Our a value in front of the x squared is a 1. Our b value is a 4. Our c value is a negative 6. When I sub that all in, some of your calculators will do it for you. You're also now sitting in front of a computer if you're watching this, so I guarantee you can find a website that you plug in your a, b, and c value and the quadratic formula solved for you. But you should know how to do it. It's grade 10 math. So when I plug these numbers in, I'm not going to write it all out, you will get two different answers for x. You will get x equals 1.15, and you will get x equals negative 5.15. So if you're looking for the total sort of issues of what does this equal, we're back here, x minus 1, x minus 2, x minus 1.15, and x plus 5.15. Okay, that is our new value. Okay, that is the factored form of our original p of x that we had equaling 10 up here. Okay, the question that you have to make sure you don't forget to answer is the original question that specifically asked us for only the positive values, which means we want x to equal 1, that's one of the factors, or 2, or 1.15. Okay? We do not want the negative 5.15. That's a negative value. So our answer would only be those three values there. Okay? There is answers when you look at this note that you should have printed out. Okay, when you look right here, it's giving you some sort of like general instructions, a plan of attack on how you want to do that. There are also two more questions for you to answer. And then a couple questions sort of to ponder on the bottom here. Let me just close my pens for a second. A couple of questions to ponder on the bottom. Why do we want one side to equal 0? Well, we want one side to equal 0 so that we can actually factor. You can't factor something where the other side is an integer of some sort, or even a real number for that matter. It has to equal 0, then we can start the factoring process. If we can't start this factoring process, then we can't go about solving it. Okay? The second point was saying, notice that we could have as many answers as the degree of the function. We could possibly have that many. So our question was degree 4, but we only had 3 answers because one of them was negative, right? We were looking for positive ones. So the question is there a minimum number of answers that we could have for odd degree and even degree functions? And if you go back to chapter 3, when we talked about odd degree and even degree, and we talked about how many possible zeros there were in each situation, we had a chart, you'll find your answer in there. So the idea that, remember, even degrees, often if we think about the shape of a parabola, an even degree doesn't necessarily have to cross the axis anywhere. Remember, so it could have 0 zeros, and if it has 0 zeros, that's the minimum number. An odd degree looks sort of like this. So an odd degree function is going up and down, changing directions. This at some point has to cross the axis, so there is at least one spot that it's crossing the axis. If there's one spot's crossing the axis, that means you have to have at least 1 0. Remember, so it can go up to the degree, in this case a quartic, up to 4. Because it was even, it could have had 0, 1, 2, or 3, 4. If we went up to a quintic, it has to have at least 1, okay, up to the degree. So any odd one, 1 to the degree number, any even one, 0 to the degree number. Okay, how could we solve polynomial equations that do not factor? Okay, that's really what we're going to get into coming up. So, okay, you can say hi in just a second. So when they don't factor, I mean, originally you'll be able to substitute some things in, but if they don't substitute in right away, then we'll have to learn a couple new methods. So this is the idea of 4.1. It's not a stretch of the imagination of anything from chapter 3. a filled-in version of it is available online for you. And then we're going to start into inequalities. So, so far I think this is probably the best method for me personally to try to talk to you guys and try to get the lesson across the best way that we would have done in the classroom. So don't forget to email if you are stuck on any homework, and I'll try my best to answer you. And just stay safe, everyone. I mean, hopefully this doesn't last too long. What's that, Marie? Okay, say hi, but don't talk in a baby voice.
Hi.
Do you know anyone in this class? No, Megan and Gracie are in the other class. I don't know if you know anyone in this class. No, grade 12.
I know.
Oh, one of the boys that played on the tennis team. His name was Owen. He's in this class. Can you say hi, Owen?
Hi, Owen.
I don't know if you know anyone else on this one.
I know. It's Jessica.
No, there's no one named Jessica. Okay, we'll see you next, 4.2. Okay, have a good day.